Yosemite National Park is world famous for its granite cliffs, including the most famous rock in America, Half Dome. But have you ever wondered how these giant cliffs got there? Well, it turns out that Yosemite's steep cliffs and dramatic ridges are the remnants of an ancient ocean that once covered this part of California. And that is just one chapter in the park's long and dramatic geologic history that stretches back more than 200 million years. So join us as we take you on a whirlwind tour through time to explore how Yosemite's amazing landscapes took shape over millions of years. Our story begins around 200 million years ago, when the coastal plain of what is now California was shattered by the rising of gigantic Sierra Nevada batholith, also known as the spine of the Sierra. As this massive blob of granite pushed skyward, it created a series of faults that cut across the coastal plain. These faults, some of which still rumble with seismic activity today, extend all the way from near San Francisco to the Nevada state line. The movement caused by these faults not only tilted the entire region, but also created grabens, or downdropped blocks bordered by faults. But our story doesn't end there. Around 70 million years ago, another batch of magma oozed up from the depths of the earth and found its way into these grabens. Over time, this magma hardened into huge masses of granite, forming the roots of today's Sierra Nevada mountains. These ancient granites, however, were not the mighty giants we know today. Instead, they were capped with layers of sedimentary rocks, including marine sediments deposited by an ancient ocean called the Farallon Sea. These sediments acted like a protective hat, shielding the granite from the forces of erosion. However, around 40 million years ago, the Farallon Sea began to evaporate. This led to the formation of large salt deposits, which were later mined by humans. But this process also had a profound impact on the landscape. As the sea evaporated, the weight of the overlying sediments decreased, allowing the granite below to slowly uplift and expose itself to the forces of erosion. This process unleashed the full force of the elements on the bare granite, which was much less resistant to weathering than the sedimentary rocks that had previously protected it. As rain, snow, and ice began to pound on the exposed granite, it didn't take long for the first deep canyons to carve into the rock. Meanwhile, the uplifted granite also created a new set of normal faults along its eastern edge. This created a series of tilted fault blocks along the eastern front of the Sierra Nevada, forming the foothills that stretch from near Sacramento to the southern border of Death Valley. It was at this point that the stage was set for the birth of Yosemite Valley. Around 15 million years ago, the Merced River began its journey through the newly uplifted granite. Initially, it flowed in a flat valley that resembled the modern San Joaquin Valley. But that was about to change dramatically. Around 7 million years ago, the river became a bit more ambitious and decided to take a detour through the uplifted granite, carving a deep V-shaped canyon as it went. This marked the beginning of Yosemite Valley as we know it today. But the Merced River wasn't working alone. Around 5 million years ago, a massive earthquake shook the region, causing the southern end of the Sierra Nevada to tilt downward. This created a nearly vertical wall of rock that funneled the Merced River toward the lowlands to the east. At this point, the valley started to resemble a giant letter V, with sheer rock walls on either side. This provided the perfect conditions for even more erosion to occur. The Merced River continued to carve through the granite, aided by the increased flow from newly formed lakes in the higher elevations. As the river flowed, it carried with it huge boulders and pebbles that ground against the bedrock, deepening the valley and smoothing the rock surfaces. Over time, this process created the polished bedrock that is a signature feature of Yosemite Valley today. As the valley deepened, the river also widened it, creating the flat valley floor that we see today. This process was aided by the formation of side canyons such as Tenaya Creek and the San Joaquin River, which diverted some of the Merced River's energy and helped to widen the valley floor. The result was a valley that was wide enough to support agriculture and human settlements, making it a desirable place to live. But our story doesn't end there. The Merced River wasn't the only force shaping the landscape. About 2.5 million years ago, the eastern wall of the valley experienced a significant cliff-building event that created some of the most iconic features in the park, including Half Dome. This event, known as exhumation, is driven by the northward movement of the Pacific Plate, which caused the Sierra Nevada to rise up and be thrust eastward. This put immense pressure on the rocks along the eastern front of the range, causing them to fold and push up into giant folds. Over time, these folds were eroded down, creating the rolling hills and ridges that we see today. However, not all the rocks were created equal. Some types of rock are more resistant to erosion than others. Then this created a battle of erosion between the different rock types along the eastern wall of the valley. The softer rocks were worn away, revealing the harder rocks beneath. This differential erosion created the dramatic cliffs and spires that define the park's skyline today, including the most famous rock in America, Half Dome. Half Dome is an enormous granite dome that towers over the valley floor. Its massive size is truly humbling. It covers an area of 19,000 acres, which is the size of Manhattan Island. And its sheer vertical drop on its northwest face is a staggering 2,000 feet. To put that into perspective, that's taller than the Empire State Building and nearly twice the height of the Washington Monument. But what makes Half Dome so special? Why is it shaped the way it is? Well, it turns out that the shape of Half Dome is the result of a complex interplay of forces, including erosion, deformation, and the type of rock it's made of. You see, Half Dome is made of a type of granite called aplite, which is relatively weak compared to other types of igneous rock. This means that it erodes more easily, which has contributed to its unique shape. As the eastern wall of the valley was uplifted, Half Dome was subjected to immense pressure, causing it to bulge upward. This created a mushroom-shaped dome of rock that was wider at the base and narrower at the top. But as time went on, erosion began to wear away at the rock, and the softer rock on the northwest side eroded more quickly than the harder rock on the southeast side. This created a cliff on the northwest side of the dome, giving it its iconic profile. But erosion wasn't the only force shaping Half Dome. In fact, the entire eastern wall of the valley was also being pushed up at the same time. This created a force known as tectonic uplift, which counteracted erosion and helped to maintain the height of Half Dome. This push and pull between erosion and tectonic uplift created a dynamic environment where the shape of Half Dome was constantly changing. The shape of Half Dome we see today is likely only a snapshot in time, and the rock will continue to erode and change over the next million years. As we've seen, the formation of Yosemite's cliffs and valleys is a testament to the power of glaciers. They reshape the landscape, leaving behind some of the most breathtaking scenery in the world. The sheer scale and grandeur of these natural wonders is a reminder of the incredible forces that shape our planet. If you enjoyed this video, don't forget to stay tuned for more exciting updates. And if you want to learn more about the amazing national parks, grab a copy of our book, which explores the fascinating history, geology, and culture of America's national parks. With stunning photography and engaging writing, this book is the perfect companion for any nature lover or armchair traveler. So go ahead and check it out. Thanks for watching.